to the viewers for watching. My name is Jonathan Dylan Peter, metric number 01 DEM21F1084. Today we would like to talk about the topic of engineering in mathematics. So first of all, I would like to say my thanks to our lecturer, Insha Abdul Hadi, our engineering mathematics lecturer. Okay, so in this today's topic, we're going to talk about, I'm going to present about engineering using a vector principle, the topic of vector, which is our chapter 5 in engineering mathematics. So I would like to give the introduction first. Okay, as we all know, and some of us have learned in our form 4 of our physics, the topic of vector. We might have learned the basics, but here in engineering maths, there is more detail about it. So just let me give the most brief introduction for vector. A vector quantity is a physical quantity that has both magnitude and direction. These are the most important main keys, which is magnitude and direction. And then here we have the definitions, the examples of vector quantity, how we can identify what is a vector quantity, how we can differentiate between scalar quantity and vector quantity. So now, what does vector quantity have? So as I've said before, vector quantity has magnitude and direction. Vector quantity has these two. And then vector quantity can be 1, 2 or 3 dimension. Scalar quantity only works for 1. But here we're talking about vector quantity. We are going to put our importance, we're going to pressurize on vector quantity because vector quantity have 3 dimensions. Okay? And thirdly, vector quantity, right? Change in vector quantity reflects either change in direction or magnitude, or the changes can occur in both also. Alright? Now the fourth is mathematical operations between two or more vectors give either scalar dot product, scalar we call dot product, or vector which we call vector product, or summation or subtraction. That means, for example, if a vector and a vector or a vector and a scalar, we put it in a mixed operations, we will get only one, which is vector only. That's what the answer we'll get back in vector form. We won't get other than that. Okay, for example, I'll give you that example that very easy for us to remember what is the units for vectors, what is the SI unit, what is the physical quantities that are used by vector. Alright, displacement, velocity, acceleration, force and momentum. So these are the physical quantities that will be used and are used for vector quantities. Alright, so that's it for my introduction. So next will be explained by Yong Kai Dong, my group member. Thank you for listening.
My name is Yong Kai Tong. Metric number is 01DEM21F1074. The application of vector is first find the magnitude of vector. Symbol of magnitude vector bracket OP of bracket A. Let OP equal bracket XY. Magnitude of vector is square root x power 2 plus y power 2. For 3-dimension vector, let OA equal xi plus yj plus jk. Then magnitude of OA is square root x power 2 plus y power 2 plus z power 2. To find the unit vector, a unit vector is a dimension vector with a magnitude of actually 1. Unit vectors are used to specify a direction and have no other practical significance. The unit vector in the direction of A can be found by A per bracket A. In order to find the sum of two vectors, triangle law of vector of parallelogram law of vector can be used. Triangle law of vector states that when two vectors are represented at the two sides of the triangle with the order of magnitude and direction, then the third side of the triangle represents the magnitude and direction of the resultant vector as in figure 5.7. Parallelogram law of vector states that if two vectors acting at a point are respected in magnitude and direction by the two adjacent sides of a parallelogram, then their resultant is respected in magnitude and direction by the diagonal passing through the common tail of the two vectors as in figure 5.8. If OA equal A, OB equal B, and theta is the angle between A and B, the scalar product is given by A dot B equal bracket A bracket B cos theta. Then to find the angle between two vectors, we use cos theta equal A dot B per bracket A bracket B. To find the cross product of two vectors, let OA equal A1I plus B1J plus C1K and OB equal A2I plus B2J plus C2K. To find OA minus OB, we use the formula in the frame.
Hi, my name is Untitled. My matrix number is 01DBM10013F1076. Today, I will explain the mathematical solution with drawing. This is the example of building with vector construction. And I will use the formula of scalar product and vector product to solve the solution. In order to find the theta in the triangle above, we should use the formula of scalar product or dot product, that is A dot B equal to magnitude of A and B multiple with cos theta. Before we use this formula, we should find the value of OA dot OB, that is equal to 25, and find the magnitude of OA and OB, that is 8.602 and 6.708. Then we can get the angle of theta is equal to 64.34 degree. We also need to find vector product of two vectors above. We need to use this formula to get the answer. And we use this formula, we can get OA multiple with OB is equal to 20I minus 39J plus 28K. And the vector of AB is equal to negative 2I plus 4J plus 7K.
Selamat sejahtera, nama saya Joshua Michael. Nombor matrik saya ialah 01DEM21F1080. Kesimpulannya ialah vektor digunakan dalam mekanik kejuruteraan untuk mewakili kuantiti yang mempunyai kedua-dua magnitud dan arah. Banyak kuantiti kejuruteraan seperti daya, anjakan, hal laju dan pecutan perlu diwakili sebagai vektor untuk analisis. Kuantiti vektor berbeza dengan nilai skalar seperti jisim, luas atau kelajuan yang mempunyai magnitud tapi tiada arah. Yang kedua, produk skalar bagi vektor digunakan untuk mencari sudut antara vektor dan dalam takrifan kuantiti fizik skalar. Seterusnya, dengan adanya vektor, banyak kerja-kerja kejuruteraan boleh dilakukan dengan lancar kerana kita dapat memperolehi ukuran yang tepat bagi sesuatu binaan. Akhir sekali, untuk membina resultant, vektor bagi dua vektor dalam tata secara geometri, parallelogram rule boleh digunakan. Jika terdapat dua vektor pada kedua-dua belah segitiga dan mempunyai magnitud dan arah, maka belah ketiga mewakili resultant vektor yang mempunyai magnitud dan arah. Itu sahaja daripada saya. Sekian, terima kasih.